Okay, section 7.2 is just going to follow along from 7.1. That's why I usually teach them together. Remember, CLT was central limit theorem. That means if I have any old population out there, it doesn't matter what kind of population it is, if it's normal or skewed or uniform or just wacky, it doesn't matter. If I have that, then the mean stays the same for the sample, and the standard deviation has to be divided by square root of n for the sample standard deviation. So, and that's if n is greater than or equal to 30. Okay, that's what we saw in the last one. We are going to look at how we use the central limit theorem when we are talking about means. All right, so how does it help us? Here's what it's doing for us. It allows us to take any other shape distribution, any crazy distribution, and use normal distribution methods. And what's great about that is it's easy. Don't we love normal distribution? You grab your table, you look things up, it's easy, okay? As long as you have largish samples, which means greater than or equal to 30. So as long as the shape of as long as the samples are large, we can use these normal distribution methods to find the mean of the sample means and the standard deviation of the sample. So the z-scores are going to undergo a change here to reflect the sampling distribution. Remember that the mean of the sample is x bar. X bar just means the sample mean, and the population mean is mu. So kind of keep those separated in your head. We've used them both now, different times. So the mean of the sample is x bar, and the mean of the population is mu. All right, here's what's going to happen. I'm going to concentrate over here first. Listen, we're going to go back and forth, and sometimes, remember our Norwegian babies? So if we went and found the z-score for a particular Norwegian baby, we would use x minus mu over sigma, okay? But if we went and grabbed a group of Norwegian babies, then we have to change that. This is going to be a sample of at least 30. Our new z-score is x bar, sample mean, minus mu sub x bar, mean of the sample means, divided by sigma sub x bar, which is the standard deviation of the sample means. Do you see how that changed? Instead of a single baby, it's the sample. Instead of the population mean, it's the mean of the sample means. Instead of the population standard deviation, it's the standard deviation for the sample distribution. Now listen, the mean of the sample means is mu, right? That's what we learned last time. They were one and the same. And to find sigma sub x bar, we did sigma divided by square root of n. So I'm going to change that one more time, and here is our fabulous formula. Here's what I want you to remember. This is for one baby, one guy off the street that you're taking his height, one person. This is for a sample. When I want to go and get a group of babies or a group of people off the street, okay, then I will use this one. So just keep those two straight in your head. Those are two separate things that we are doing. The real change here is right there. That changes everything. You see how the rest of it's all the same? But when I divide by square root of n, that changes it to be for the sample. That'll change your z a lot. So you have to be careful that you're looking at one person or a group of people, or cars or airplanes or whatever, okay? So let's try it without words. I have finding the z-score of the given sample mean using the CLT. CLT means using that x bar minus mu over sigma over square root of n. So I want to find the z-score. My formula was x bar minus mu over sigma over square root of n. Here goes nothing. X bar is, I know the bar is kind of lost in there. That bar is so far up and I don't know why. 0.52 minus mu over sigma over square root of n. And we're going to go and put that in our calculator very cautiously. Use your fraction function or use good parenthesis action. If you are doing things well, you should get 1.94. Okay, remember z-scores are 2 decimal places. Then we can look them up on the table. Okay, so calculating the z-score, it'll either tell you use the CLT or it'll say for the sampling distribution. Okay. All right, we're going to throw words in it in the next video. So click on over to the next one and we'll toss some words in and make it fun.